In this lecture, we are going to discuss about locus. What is locus? Locus is a point moving on a plane in such a way that it always maintains certain conditions. So how we find out locus of a point? We always say, let x comma y be any point on the locus, and then we find a relation between x, y and some other constants. Okay, and that is the equation of a locus, and we interpret the nature of the locus. In complex number also we will do the same thing. Suppose we have been given mod z is 1. Now we have to interpret this result on a complex plane. That is, we want to find out the locus of the point z. So for here, what we will do, we will replace z by x plus iota y. Because xy is any point on an Argan plane which is represented by z, because z is an arbitrary point. That is, x comma y is an arbitrary point on the Argan plane. So if we replace, we are going to have modulus of z means under root x square plus y square, which is equals to 1. So that implies x square plus y square equals to 1. This represents a circle whose center is at the origin and radius is 1 unit. Is it clear? This represents a circle on an Argan plane whose center is at the origin and radius is 1 unit. If I say mod z is 2, from here you can say now, without replacing z by x plus iota y, we can easily say that this represents a circle whose center is at the origin and radius is 2 units. Is it clear to all of us? That is, if mod z is a, then this always represents a circle on a complex plane whose center is at the origin and radius is a unit. Okay, now if I say mod z is greater than a, what do you mean by that? Mod z equals to a is a circle whose center is at the origin and radius is a. Now if it is greater than a, then the point z lies anywhere outside the circle whose center is at the origin and radius is a. Yes or no? Because if this is the circle, this equation is mod z say equals to a, then this point is what? This is the radius. This is the radius. Therefore, the coordinate of this point will be a comma 0. Now, mod z, z is any point on the Argan plane. So, that point lies outside the circle whose radius is a. Yes or no? That is, we are talking about all the region outside the circle, and that is the locus of the point z. Yes, it will not touch the circumference of the circle because there is no equal sign over here. If mod z is greater than or equals to a, then we will say the point is lying outside the circle, that's for sure, as well as it will take the points on the circumference of the circle also. Is it clear? Is this conception clear? Now suppose if I say that mod z is less than a, what do you mean by that? Z is any arbitrary point on the complex plane. Mod z is less than a means this represents all the point inside the circle whose center is at the origin and radius is a units. Yes? Now let us combine these two results. Let us say mod z is greater than 1 and less than 2. In that case, what will happen? What will be the locus of z? The locus of z will be, first let us take this part. Mod z is greater than 1 means there is a circle whose center is at the origin and radius is 1 unit, and we are talking about all the region which is outside this circle. Yes or no? Z is any point lying outside this circle, mod z equals to 1. Now, when mod z is less than 2, what do you mean by that? There is another circle whose center is at the origin and radius is 2 units, but less than 2. Less than 2 means that z is lying everywhere inside the circle mod z equals to 2. Yes? So we are talking about any point inside this circle, right? Now we have been said mod z is greater than 1, less than 2. So we have to find out the common region which satisfies both these inequations. So naturally the common region will be this portion only. Yes or no? I am shedding it. Because this is a portion where z is less than 2 as well as it is greater than 1. Is it clear or not? Absolutely. Okay. Now, what do you mean by modulus of z1 minus z2? Let us say z1 is x1 plus iota y1 and z2 is x2 plus iota y2. Therefore, z1 minus z2 is x1 minus x2 plus iota, y1 minus y2. And modulus of z1 minus z2 is under root x1 minus x2 square plus y1 minus y2 whole square, right? So this represents basically the distance between 2 points whose coordinates are x1, y1 and x2, y2. So from this complex number representation, we can say mod of z1 minus z2 means the distance between z1 and z2. Is it clear to us? Okay. Now, let us say I've given you mod of z minus z1 is a. What does this represent? Without replacing z by x plus iota y, we will simply represent from this complex number equation. Okay. Now, mod of z minus z is a variable point, but z1 is a fixed point. Z minus z1 modulus is basically the distance between z and z1, where z1 is a fixed point and z is a variable point moving on the plane, in such a way that the distance between z and z1 is always a. Therefore, the locus of z will be what? It can come here, this distance is a. It can come here, this distance is a. It can come here, the distance is a. Everywhere the distance is a. Okay, so z is moving on the circumference of a circle whose center is at z1 and radius is a. Is it clear? So modulus of z minus z1 equals to a represents a circle whose center is at z1 and radius is a. Let us say, for an example, if I say z minus 2 is 3, what do you mean by this? This basically represents a circle whose center is at 2, 0 and radius is 3. Yes? Let us take another example. Mod of z minus 2 minus 3 iota is 3. What do you mean by this? It means mod of z minus 2 plus 3 iota equals to 3 means it represents a circle whose center is at 2, 3 and radius is 3 units. Is it clear? Now, we can just extend this one a little bit. If I say z minus 2 is greater than 3, what do you mean by this? This means we are talking about those points of z which lies outside the circle whose center is at 2, 0 and whose radius is 3 units. Let us say the center is 2, 0 and radius is 3 units. So z is a point which is lying outside this circle without touching the circumference of the circle. Yes or no? So that is the locus of z. Have you understood it? Now I can extend this same conception a little bit and we can say, if I say mod of z minus 2 minus 3i is greater than 3 and less than 5. What do you mean by this? Here we can say, in context to the previous example, we can say that this represents, suppose let us take this one. This represents that z is lying outside the circle whose center is at 2, 3 and whose radius is 3. Yes or no? from this part, you can say that the complex number z is lying somewhere outside the circle whose center is at 2, 3 and radius is 3 units. From this one, we can say that z is lying somewhere inside the circle whose center is 2, 3. How this 2, 3 is coming? I have shown this calculation over here. So z is lying somewhere inside the circle whose center is at 2, 3 and radius is 5 units. Therefore, this whole inequation will represent the portion between the two circles whose radius are 3 and 5 respectively. Yes or no? Same thing as we have done here. So this graph will look something like this on an Argand plane. This point, let us say this is 2, 3. So there is a circle whose center is at 2, 3 and radius is 3 units. So this is greater than 3 means we are talking about the outside region, and another circle center is at 2, 3 but radius is 5 units, and that time your z is lying inside the circle. So we are talking basically about this common region. Yes or no, tell me. I'm shedding it. Okay? So this is the region where your z lies, which satisfies this inequation. Is it clear to all of us? Okay, let us take some other examples. Now, if I take an example like 2 is less than real part of z is less than 5. What do you mean by this? Interpret this result on a complex plane. Real part of z means nothing but x. If z is x plus iota y, then what is real part of z? That is nothing but x. And imaginary part, y. So real part is greater than 2, less than 5. So let me just draw it on an Argand plane. X equals to 2 is this line. This is x equals to 2. Okay, from this. But x is greater than 2. So we are talking about this region, right? Now let me take the second part where x is less than 5. X equals to 5 is a line which is parallel to the y-axis. Okay? But x is less than 5. Then we are talking about this region, not touching the line. Now, x is greater than 2, less than 5. Which region will satisfy both these conditions? Naturally, we are talking about the region which is inside these two parallel lines. Is it clear? Are you understanding the locus? How to interpret the result on a complex plane? Okay, let me take another example. If the same question if I give you, imaginary part of z is greater than 2, less than 5. Imaginary part of z means it's y. So y is greater than 2, less than 5. Now, y equals to 2. This is a line which is parallel to the x-axis. This is y equals to 2. Y is greater than 2 means we are talking about this region. Definitely not touching the line. Y is equals to 5 is another line which is parallel to x-axis. This is y equals to 5. But now in this case it is y is less than 5. Then we are talking about this region. Now, which region will satisfy these both conditions? Naturally, the region between these two parallel lines where your complex number z is lying. Yes or no? Have you understood this? Okay. Let us take some other examples here. Now, if the question is mod z equals to mod of z minus 4, locate the complex number on the complex plane. So how to do this? Now, first of all, we have to understand what is mod z. Z is any arbitrary point. It is moving on the complex plane. What is mod z? It is the distance of that variable point from the origin. Okay? From the origin. And that distance is same as the distance of that point from the point 4, 0. Yes or no? Because z minus 4 means what? It is the distance between z and 4, 0. So these two distances are same. Let me just draw it. 4, 0 is somewhere at this point, let us say. Okay. So z is such a point moving in such a way that if suppose z is here, this is the origin, so the distance from this point is our z, is same as the distance from these 2 points. Yes or no? That exactly what represented by mod z equals to mod of z minus 4. The distance of the point z, the variable point z from the origin, is same as the distance of that variable point from the point 4, 0. Now that point can be, the variable point can be this point also. In that case also, this distance and this distance, they are same. Similarly, the point can be here also. In that case, this distance and this distance, they will be same. Similarly, the point can be here also. Then this distance and this distance are same. Yes or no? So in that case, what we are getting basically, look it very carefully. The locus of the point z, that is the variable point z, will lie on the perpendicular bisector of the line joining the point 0, 0 and 4, 0. Yes or no, tell me. Because if there are 2 points, say x1, y1 and x2, y2, then any point on the, let us say this is the perpendicular bisector. If this is the perpendicular bisector, then any point on this perpendicular bisector will have a equal distance from x1, y1 as well as from x2, y2. Is it clear? Therefore, mod z equals to mod of z minus 4 represents the locus z. Or we can say the complex number z will lie on the perpendicular bisector of the line joining 0, 0 and 4, 0. As simple as that. So from here we can generalize the equation like z minus z1, if it is equals to z minus z2, then this represents the complex number z. We are trying to find out the location of the complex number z, that is the locus of z. The locus of z will be lying on a line which is perpendicular bisector of the line joining z1 and z2. Is it clear or not? Tell me. Okay. Now let me just extend this same problem a little more. If I say locate the complex number z where mod z is greater than mod of z minus 4. Now you tell me. Mod z is greater than mod of z minus 4. It means what? That is the distance of that point z from the origin is greater than the distance of that point from the point 4, 0. Yes or no? So, let me just draw the diagram once again. This is our 4, 0. This is our origin 0, 0. Now, this is the perpendicular bisector. Naturally, this point will be 2, 0. Now, observe one thing. If z lies somewhere here, then this distance will be less than the distance from the point 4, 0. Correct or not? But if the point is lying somewhere in the right hand side of x equals to 2, then this distance will be more than the distance from the point 4, 0, which will satisfy this inequation. Yes? So what you will say? The complex number z is lying somewhere in the right hand side of x equals to 2. Therefore, its locus will be x is greater than 2. In other words, you can say that the real part of the complex number z is greater than 2. Okay? Yes or no, tell me. Therefore, the complex number z is lying anywhere in the right hand side of x equals to 2 means x is greater than 2 is the locus of the point x, y, or else you can say that is the location of the complex number z on a complex plane. Is it clear to us? Absolutely. Okay, now let us take some other example. Find out the locus of z for which mod of z minus 1 plus iota is equals to mod of z plus 1 minus iota. Let me just rearrange this. So from here, it indicates that the distance between the variable point z and the point 1 comma minus 1. And this indicates the distance between the variable point z and the point minus 1 comma 1. Is it clear? Now the line which contains these 2 points, just by inspection you can say the equation will be y equals to minus x. Y equals to minus x is the line on which the point 1 comma minus 1 and minus 1 comma 1 lies. Or else, if you cannot do it by inspection, you can use 2-point formula to find out the line which contains this 2 point, which will be Is it clear? So we got the equation of the line which contains 1 comma minus 1 and minus 1 comma 1. We can easily find out that the slope of this line is nothing but minus 1. Let me just draw it. This point is, and this point is. Now, any line which is perpendicular to this line will have a slope 1. And if it passes through the midpoint of this line, first of all, we have to find out what is the midpoint of the line joining these 2 points. The midpoint will be, which is nothing but 0 comma 0, which is the origin. Therefore, any line which is perpendicular bisector of the line joining these 2 points, or else you can say the equation of the line which is perpendicular bisector of the line y equals to minus x is nothing but a line will have a slope of 1 and passes to 0 comma 0 is nothing but y equals to x. As we all know that when mod of z minus z1 equals to mod of z minus z2, your z lies on the perpendicular bisector of the line joining z1 and z2. Therefore, in this case, the complex number z will lie on the perpendicular bisector of y equals to minus x, which is nothing but y equals to x. Is it clear? Therefore, the location of z or the locus of z will lie on the line y equals to x. Have you understood it? Let us take another problem. See this problem. It is mod of z plus 1 plus mod of z minus 1 is 4. It means what? That the distance of the variable point z from the point minus 1 comma 0 and the distance of the variable point z from the point 1 comma 0, the sum of these 2 distances will be equals to 4. Is it clear? Let me just denote this point by s dash, which is minus 1 comma 0, and s be the point whose coordinate is 1 comma 0. So variable point is anywhere here. The sum of these 2 distances, let us denote this thing as p. The sum of the 2 distances, that is s dash p plus sp, is equals to 4. That exactly what is given over here. This point is a variable point z. Is it clear? Now this is on the x-axis. This is the origin. Now suppose when the point comes here, let us say when the point comes here, that is the point P is on the x-axis, then what you will write? S dash P plus SP. S dash P plus SP is 4 given. S dash P can be written as S dash S plus SP, and SP is there, which is equals to 4. Is it clear? S dash P has been replaced by S dash S plus SP. S dash S plus SP is nothing but S dash P. Okay, that implies S dash S plus 2 times SP is 4. The distance between S dash and S is nothing but, S dash and S is nothing but 2. So 2 times SP is 4. That implies SP is nothing but 1. Is it clear? Therefore, this distance is 1. Now, tell me, if this is the origin O, then what is OP? In this case, what is OP? OP is nothing but OS plus SP, which is 1 plus 1, that is 2. So actually the equation whatever is given to us is basically coming to in this form, that S dash P plus SP is what? It is 2 times 2. And can you remember about the locus of an ellipse? The locus of an ellipse is when S dash P plus SP becomes twice of A. A is the coordinate, A comma 0 is the coordinate of the vertex, one of the vertex. The other vertex will be minus A comma 0. So whenever S dash P plus SP is 2 times A, then we always say that the locus of that point is an ellipse. In this case, observe carefully, it is coming exactly the same one, because this one will be the vertex. If this one is the vertex, this distance is how much? This distance is 2. And the sum of these distances, S dash P plus SP, is 4, which is 2 times A. Therefore, it represents an ellipse whose foci are at minus 1 comma 0 and 1 comma 0. That is, the locus of the point Z is on the circumference of the ellipse whose foci are minus 1 comma 0 and 1 comma 0. Have you understood? Have you understood this question? Okay, let us take another problem. See the question. Locate the complex number Z in the Argand plane where log mod Z minus 2 base half is greater than log mod Z base half. Is it clear? So this can be written as mod of Z minus 2 is less than mod of Z. You know why? Because this is the property of logarithm. You see, log A base B, if it is greater than M, then A will be greater than B to the power M when B is greater than 1. A will be less than B to the power M when B is lying between 0 and 1, correct? In this case, the base is half. So actually, what happens if I say log B base A is greater than log M base B. Now, here if B is lying between 0 and 1, so what you can write? A can be written as less than B to the power log M base B, which is same as your A is less than M. Have you understood it? So in this case also, mod of Z minus 2 will be less than mod of Z. Okay. Now what does this represent? Just now we have done. Mod Z means the complex number Z, the distance between that complex number Z, that variable point Z from the origin, and this distance is more than the distance of that point from the point 2 comma 0. 2 comma 0 is somewhere here. Okay. The perpendicular bisector is this point is 1 comma 0. Mod Z is more than mod of Z minus 2 means the point is lying somewhere in the right hand side of x equals to 1. Tell me yes or no. Because somewhere if you take this point Z, this distance will be more than this distance. And that exactly what this inequation represents. Therefore, your Z, that is the complex number Z on the complex plane, will be on the right hand side of x equals to 1. Therefore, its locus will be x is greater than 1. Is it clear or not? Absolutely. Okay. In this problem, they have said to locate the complex number Z on an Argand plane. So, in this case, what we will do? Again, the same rule. These are all basic funda of your logarithm. Those who have not done it, I have given the link in the description box. You can check it. Logarithm videos there. This can be written as less than 1 by root 3 whole to the power minus 2. Why it is so? I have explained before. Because 1 by root 3 is lying between 0 and 1. Okay? Let me just cross multiply, because mod z plus 2 cannot be less than 0, right? It is a positive number. So I can cross multiply. 3 mod z plus 6. Let me take everything in the left hand side. So we are having basically, I'm going for middle term breaking. Is it clear? Now mod z plus 1, this is always positive. Therefore, the only solution is mod z minus 5 is less than 0. So that implies mod z is less than 5. Is it clear? This is the locus. Now, if I ask you to interpret the result, you will say mod z equals to 5. This represents a circle whose center is at the origin and radius is 5 units. And it is less than 5. Therefore, the complex number z is lying anywhere inside the circle whose center is at the origin and radius is 5 units. Have you understood? Have you understood the location of the complex number z on the complex plane for this problem? Okay, let us move for the next problem. Again, the question is locate the complex number z on the complex plane. Cos pi by 3. Cos pi by 3 is cos 60 degree, which is half. So here we can write with the same argument. Have you understood it? I've changed the sign. So if I cross multiply, we are going to have. Now you can ask me one question, sir, why you have multiplied in this case? It may so happen that 3 times mod z minus 1 minus 2 is less than 0. It may so happen, but no, it is not possible. Can you tell me why? Otherwise, this function will not be defined. Why I'm telling you? Because you see, inside the log, whatever there is, it has to be positive. Mod of z minus 1 plus 4, guaranteed it is positive. Therefore, 3 times mod of z minus 1 minus 2 has to be positive. Otherwise, this function will not be defined. So that is why I have cross multiplied with 3 mod z minus 1 minus 2. Understand it very carefully. So here we are getting that implies. Now can you predict about the locus of z? Or else we can say about the location of the complex number z. Very simple. What we know about mod of z minus 1 is 10. What do you mean by this? This represents a circle whose center is at 1, 0 and radius 10 units. Okay? Center is at 1, 0 and radius is 10 units. Okay? Now, we have been given mod of z minus 1 is greater than 10. It means that z, that variable point on the complex plane, lies somewhere outside the circle whose center is at 1, 0 and radius is 10 units. Is it clear? So that is the locus of z, or you can say that is the location of the complex number z on the complex plane. Is it clear to us? Okay. Please make a note of it. Argument of z is theta. It represents, if this point is z, this is the origin and this angle is theta. So arc z equals to theta represents points, non-zero points, on ray, non-zero, be very careful, non-zero points. Z cannot be 0. That is, z is not touching the origin. So this point is open. Is it clear? So it represents points non-zero on ray emanating from origin, making an angle theta with the positive direction of the real axis. So what does arc z equals to theta represents? It is a ray emanating from the origin and making an angle theta with the positive real axis. Is it clear? Absolutely. In the other word we can say, suppose if I say arc of z minus z1 is theta. What do you mean by this? This is again, z is lying on the ray emanating from the point z1 but not touching z1 and making an angle theta with the positive direction of the x-axis. We can assume in this way. Suppose this point is z1. So a ray emanating from this point, your z can lie anywhere on this line. And this line is making an angle theta with the positive direction of the x-axis. That exactly what argument z minus z1 equals to theta represents. Is it clear to us? Let us take a problem based on this. Solve for z which satisfy argument z minus 2 minus 4 iota is pi by 6 and argument z minus 2 minus 6 iota is 2 pi by 3. We have to solve this. Let me just draw the diagram on the complex plane. Let us consider the first equation. Arc z minus is equals to pi by 6. What do you mean by this? This means that a ray emanating from the point 2, 4, let us say this point is 2, 4, emanating from this point and making an angle pi by 4 with the positive direction of the x-axis. So for this equation, your z is lying anywhere on this ray except the point from where it is emanating. That is the point 2, 4. Z cannot take the value 2, 4. Yes or no? Okay. And for the next one, the second equation represents that Z is lying on a ray emanating from the point 2, 6. 2, 6 is somewhere here, let us say. So this point is 2, 6. It is emanating from this point and making an angle 2 pi by 3 with the positive direction of the x-axis. Therefore, the ray will pass something in this way. Yes or no? Because this angle will be 2 pi by 3. Okay. So our graph is, for the first one, your z is lying somewhere on this ray. And for the second one, your z is lying somewhere on this ray. So obviously from the given graph, we can see that there is no common z which will satisfy both this equation. Hence, our answer will be, there will be no solution for this case. Is it clear or not? Absolutely. Let us take another example. See this question. Sketch the region given by argument z minus 2 minus iota is greater than equals to pi by 6. It means what? Argument of z minus 2 plus iota is equals to pi by 6. What does it mean? Where does this z is located on the complex plane? Here z is basically lying on the ray emanating from the point 2, 1 and making an angle pi by 6 with the positive direction of the x-axis, right? Now it has been said in the question that the argument of this is greater than equals to pi by 6. We know from the principal argument, arc of z always lies between minus pi and pi. Okay? As the argument z minus 2 plus iota is greater than equals to pi by 6, therefore, your z will lie anywhere in this region. Yes or no? But it cannot exceed pi. Because in the principal argument, the argument is bounded in the region minus pi to pi. Therefore, z lies anywhere in this region touching this line. What I want to say is that the complex number z on the Argand plane can be anywhere on this line or in this region, because anywhere the point z is considered in this region, the argument will be more than pi by 6. If the point is here, then the ray will emanate from the point 2, 1, but the argument will be this angle, which is more than pi by 6. So anywhere in this region, this shaded region, your argument is greater than equals to 6. Is it clear? Therefore, the locus of the point z is in this shaded region. Have you understood? Including this line. Including this line, including this line. That is, the complex number z can be anywhere on this line as well as can be anywhere on this line also, including this region. Is it okay? Let us take another example. The question is same. Sketch the region given by mod z is less than equals to 5 and argument z minus 2 minus iota is greater than pi by 6. Not equals to, greater than pi by 6. So again, this is the same question like this. The ray will emanate from the point 2, 1, but this is open. It will emanate from 2, 1 and the angle made with the positive direction of the x-axis will be pi by 6. This angle is pi by 6. Now you see, for the second equation, your z will lie anywhere in this region, but excluding the points on this ray, because there is greater than no equal sign is there. That is, z cannot take any point on this line, because any point on this line, the argument will be equals to pi by 6. But in the question it is given, the argument is more than pi by 6. Therefore, the point can be anywhere in this region, but not exceeding pi also, because in principal argument always lies between minus pi and pi, as I defined in the above problem. So your z can be anywhere in this region, excluding this emanating ray, but it can be on this line also, which will satisfy this condition. Yes or no? Okay. Now let us consider mod z is less than equals to 5. Mod z equals to 5 is basically a circle whose center is at the origin and radius is 5 units. Now this point is 2, 1. This point is very much within the circle, right? Because this point is 5, 0. This point is 0, 5. Okay, but z is less than equals to 5. Means for this inequation, your z will lie anywhere inside this circle. Therefore, we have to find out a common region which will satisfy this inequation as well as this inequation, right? And that from the given diagram we can easily say that this shaded region is that required region where z is lying, which satisfies both these conditions. Okay? It will include the points on the circumference of the circle for this arc. For this arc, the points on the circumference of the circle will be considered because there is less than equals to 5. Is it clear to all of you? Absolutely? Okay.